Chapter 1, Video Notes, Solving Equations. I'm sure you have experience with solving equations, but solving equations is a big part of algebra. And remember, our goal with solving equations is to find the value of the variable which makes our equation true. Okay. Another way we describe it is we say we want to get x all alone. So when you're solving an equation, there are some steps you can go through. Number one, you'd like to combine like terms on each side of the equal sign. If you look at example C below, we have on the right side of that equation two terms with x in them. So that's one thing we want to do is combine those terms into one term. Number two, get all the x's on one side. You'll notice in example B that I have x's on each side of the equal sign. I'll want to bring those together into one term, which is a little bit different than what we did in C. What I'm hoping for is to get the equation to look like example A, where the variable is only on one side of the equal sign. And then I can move all the operations away from that variable and solve for it. So like on example A, I'm going to get rid of the plus 2 and the times 5, so that at the end, all I have is x equals my solution. So those 4 steps are steps that you may have to go through as we solve these equations. So let's look at letter A. A is the simplest of the 3 examples because the variable is already on one side of the equal sign. So all I need to do is get rid of the plus 2 and the times 5. Now, the order you get rid of those in is important. And what we do is the opposite of the order of operations. So in the order of operations, multiplication and division come before addition and subtraction, but not when we're solving. When we're solving, we get rid of addition and subtraction first. So since I have a plus 2 right here, the way we get rid of it is doing the opposite, which would be subtracting 2. And you have to subtract 2 from both sides to keep the equation equal. Some of you are probably familiar with the method of drawing a line through the equal sign and keeping the 2 halves of the equation separate. That's fine if you'd like to do that. It's not required. But on the left-hand side, the plus 2 and minus 2 would cancel out, leaving 5x. And on the right-hand side, 12 minus 2 would be 10. Next, I would get rid of multiplication or division. And I have a multiplication times 5 here, so I would divide by 5. Then I would cancel the 5's, and 10 divided by 5 is 2. So my final solution is x equals 2. When we're solving equations, it is always a good idea to check your work. And that means taking the solution you found and plugging it back into the original equation and see if the equation would be true. So if I plug that 2 into the equation above, I would have 5 times 2 plus 2 equals 12. Well, 5 times 2 is 10. 10 plus 2 is 12. 12 is equal to 12. Therefore, I know I solved that equation correctly because when I plug it in, it makes the equation true. Now, example B has one more step we need to add, and you can probably see the difference between A and B, but B has x's on both sides of the equal sign. So when that's the case, I need to combine those together on one side of the equal sign. My suggestion is that you move the smaller of the 2 x's to the other side, because that will make the number in front of the x, we'll keep it positive. So x is smaller than 3x, so I would move the x to the other side. And you have to do the opposite. So it's plus x right now. So I would subtract x from both sides. 3x minus x would be 2x. And on the right-hand side, that positive x and the subtract x would cancel each other out. Now I'm in the same position I was in example A, where I will get rid of addition or subtraction first. So I'm going to get rid of the minus or subtracting 6 by adding 6 to both sides. 8 plus 6 is 14. And then I'm going to get rid of multiplying by 2 by dividing by 2 on both sides. So that cancels, and my final answer is x equals 7. And again, we can plug that into the equations if you wish to check your answer. I'm going to have to plug it into both sides this time, though. So the left-hand side would be 3 times 7 is 21, and 21 minus 6 would be 15. And if I plug 7 into the right-hand side, it'd be 7 plus 8 is 15. Since they're both equal to 15, the equation is true, and I have the correct solution. So you should never get a solving question wrong, because you can always check your answer first, and if your answer is incorrect, you could resolve it. Example C is the most complicated example. You notice there's x's on both sides of the equal sign, but there's actually 2 x terms on the right-hand side of example C. So I'm going to have to add one more step, which is step number 1 from our list, combine like terms on each side of the equal sign. So before I solve this one, or as I start to solve it, I'm going to combine those 2 terms first, because they're on the same side of the equal sign. So 7x plus 2x is 9x. Now I have a problem that looks like example B, where I have x's on both sides of the equal sign. So I should move one of those x's to the other side so that they're all together. And my suggestion is you move the smaller of the 2. You don't have to, but it does keep the x term positive if you do. So I think negative 4x is smaller than 9x. So I'm going to do the opposite by adding 4x to both sides of the equation. These 2 cancel out, leaving me 6 equals 9x and 4x is 13x minus 7. Now I have a problem that looks like example A, where I want to get rid of the subtracting 7 and the multiplying by 13. Remember, we do the order of operations in reverse of PEMDAS. So I'm going to get rid of the addition or subtraction first. So I'm going to get rid of the subtract 7 by adding 7 to both sides. So I get 13 on the left and 13x on the right. These 2 will cancel out. And then I want to divide both sides by 13. And those 13s will cancel out. My final answer is 13 divided by 13, which is 1. You can then plug that 1 into the equations above to see if you solve them correctly. When you do that, on the left-hand side, you get negative 4 times 1 is negative 4, and negative 4 plus 6 is 2. So the left-hand side is 2. And the right-hand side, 7 times 1 and 2 times 1 are both just 7 and 2. 7 plus 2 would be 9, and 9 minus 7 would be 2. So we did that correctly. We have solved. We know we are correct. So follow the steps for solving. We will spend more time later in the course solving equations in greater detail, but this should be just a little bit of review from your solving equations in the past. Good luck.